So our last talk for this session is titled 3D Turtle Coding Activities for Korean Primary Education.
Sorry. Hello, I'm Choi Lee. I'll present the title of 3D Turtle Coding Activities for Korean Primary Education. The content is as follows. First, introduction. Second, 3D Turtle Coding Activity. Third, 3D Turtle Coding Activity in a smartphone environment. Fourth, 3D Turtle Coding Activity for primary math education. Fifth, closing remarks. Here are the following the two 3D objects. Then I'll ask you to the question, are the same or different? Same? Different? Yeah, it's different. How did you solve the problem? In general, to solve this kind of problem, we usually rotate the object mentally until a comparison can be made. So how can you explain definitely when someone asked why it is different? Maybe you couldn't explain to them well because you mentally rotate. So how can you express the following shapes? Arabic numerals is a representation system about numbers. Due to Arabic numerals, we communicate with each other effectively. And Arabic numerals help us to think. However, what is the representation system about 3D objects like Arabic numerals? In other words, how can you express the 3D object? We need the representation system about 3D objects like Arabic numerals to communicate with each other effectively. Now I'll show the content of the revised mathematics textbook for 6th grader in elementary school. The subject is asked to compare among options of rotate 3D object to tell which option matches the object A. So which one is the same as A among options of rotated 3D object? Green one, yellow one, or blue one? The answer is green and blue one. How can you solve the problem? Is it easy or difficult for 6th grader students? It is more important to think about problem solving and communication between students or between students and teachers in the classroom. What do you think? This is another content of revised mathematics. textbook for 6th grader in elementary school. This is more difficult than before the problem. The answer is, if you put B and C together, will they become D1 or D2? The answer is yes, D1, yes, D2, yes. So how can you solve the problem? If you solve the problem, how can you explain to others? Maybe it is not easy to explain it to others because there is not appropriate expressive system for 3D object. So we also expect that the schools will be suffered from a lot of difficulties such as communication between students or between students and teachers in the classroom and problem solving. The content of Korean mathematics textbooks 3D building block is aimed to developing spatial ability. Spatial ability as one of the important factors of human intelligence is a cognitive function that is often used in various academic areas like mathematics, architecture, and medical science, as well as in our daily life activities like driving and swimming. With the development of technology, spatial intelligence is becoming increasingly important. This is a website of Spatial Intelligence and Learning Center. SILC brings together scientists and educators from many different institutions to pursue the overarching goals of understanding spatial learning and using this knowledge to develop programs and technologies that will transform educational practice, helping learners to develop the skills required to compete in a global economy. SILC participants include researchers from cognitive science, psychology, computer science, education, and neuroscience, as well as practicing geoscientists and engineering who are particularly interested in spatial thinking in their fields, and teachers. So we need to think about spatial learning. And I'll present a solution about difficulty of a Korean primary mathematics class. It will also make the student possible to enhance spatial intelligence. We have presented our studies in Constructionism conference. So I'll introduce our studies we have presented. Traditional logo constructed geometrical object with forward and rotate commands and shares a fundamental philosophy with Lego bricks, which build a variety of 3D objects with basic blocks. Based on the basic idea of Lego, Joe designed the representation system in a virtual micro world, which constructs 3D building block as a Lego bricks do. 3D toucher representation system is composed of action letters S that move forward, action letters R and L that turn to right and left, and action letters U that move upward, downward using toucher metaphor. The toucher representation can be used building various shapes with dynamic animation. By using that, student can make dynamic Lego blocks and dynamic creative objects, and student can construct the knowledge by creating and communicate through the symbol-based artifacts. The toucher representation could be familiar with students while constructing their own artifacts which are meaningful for themselves. The traditional process that served as a communication channel between toucher agent and human has now evolved into communication between human and machine with the spread of 3D printer. The artifact made in virtual world now can be printed to real world. Consequently, we designed and applied 3D toucher coding activity based on the study by Jeong study, and with the two following steps. These activities were based on the 3D toucher representation system and 3D printer. Sorry. First, mentally constructing the floor surface of a 3D object by using a 3D printer metaphor. 3D printers started from the floor surface, piled layers on it, and printed out 3D object. So the students were advised to perceive a 3D cube stack considering the floor surface as the reference surface. Step 2. Second, coding 3D cube stacks such as a sequential process from the perspective of toucher standard on the floor surface of a 3D object. The students were required to regard the 3D cube stacks as a sequential composition process. Oh. Now, I'll introduce the learning environment where students design personally meaningful artifacts. If you get on this site on the smartphone, you can see the following screen. If you get on, click those button and cube, toucher, and we can know the toucher position. And you can also change the color of cube and big, small. And you can copy the URL to share the artifact through the social media. Copy URL. And capture. You can see the artifact that your friend designed and share with their thoughts and ideas. And you can develop the artifact that your friends are already made. And I'll introduce the artifact that students create in the smartphone environment. This is the shape of heart, giraffe, penguin, watch, fish, name, boat. This shows the artifact that a student designed in a smartphone environment through 3D touch coding activity and shared and communicated through social media by each other. This shows the artifact called Firefighting Helicopter. A student designed the artifact in a smartphone environment after seeing news of a forest fire in California recently. And the student posted the link to the internet news on the forest fire in California through social media. Then a friend compliments such as, "It's cool, but a wonderful thought and well done." Therefore, this will be a powerful tool for coding education at primary school by providing a learning environment where students design personally meaningful artifacts in a smartphone environment through 3D touch coding activities. Another example shows an Eiffel Tower created by another student in a smartphone environment. At first, the student constructed the artifact using the touch symbol such as 1. However, the student felt inconvenienced because of a step for toucher to go and come back to a certain point. For example, this command is the shape and bracket command. Remember the position. Then light bracket is the remember position and make the artifact. After revising commands, the students said the usefulness of bracket symbol. I think the bracket symbol is useful because I can create shape without having to return to certain point. It's fascinating. By providing students with a learning environment where they could design artifact, we enable them to feel the power of the total symbol and to experience learning by design, where learning is mentally constructed in the design process. Now I'll present the 3D touch coding activity to primary math education. The problem on left hand is related to mental rotation, where the subject is asked to compare two 3D objects rotating some axis and stated if they are the same image or if they are mirror images. According to the Shepard Metzler study, the response time increased relative to rotation degree when conducting MRT. It was revealed that when we solve the problem, we mentally rotate as we physically rotate. We apply total perspective to this kind of problem. This study said two types of spatial imaginary transformation, allocentric spatial transformation, which involve an object-to-object representational system and encode information about the location of one object or its parts with respect to other objects, versus egocentric perspective transformation that involves a self-to-object representational system. In general, to solve this kind of problem, we usually take an allocentric perspective involving an object-to-object representational system because we mentally rotate. But the toucher's metaphor would provide egocentric perspective involving a toucher-to-object representational system. So 3D toucher coding activity was applied to the problem with two steps to take the toucher perspective. According to the step of activities, the green one is left type, the yellow one is right type, and the blue one is left type. And the object A is left type according to the steps. So A is the same as green and blue one. To show the effect of the 3D touch coding activities in mathematics education, pre- and post-tests were conducted. 21 middle school students were conducted. Our participants were pre- and post-tested before and after activity and participated in this activity with the researchers for 75 minutes each day for 2 days, followed by post-test. The students solved 3 example items before the test with the researchers so that they are familiarized with the test. We designed the test based on the content of textbook. To solve the problem, we need to remove the piece of C on D1 and discriminate the remaining 3D object it was B or not. So we designed tests like this. The tests were conducted on personal tablet computers, and student answer and response time per question were recorded by clicking the answer. In the test, students were presented with the 3D object C consisting of B and a soma cube piece put together, and to determine whether after the removal of the piece B, the remaining 3D object was L or R. Here, they were to make a distinction under the restriction of the left type L and the right type R of the soma cube. When the data of 21 students were analyzed from pre to post test, student average score increased significantly. Score increased, reaction time decreased. Now, finally, I'm close remarks. Pepper has stressed the importance of powerful ideas that can be used as tools to think with over a lifetime. We provide not only a solution to difficulty in mathematics and coding education at primary schools, but also ideas with leverage to students. We come confirm the possibility of expanding the cognitive skills of spatial ability by prompting students to take a structure and systematic approach to 3D cube stacks through 3D touch coding activities. Also, 3D touch coding activities are expected to play the role as a bridge between primary school and middle schools in both mathematics and coding education, which will make the student possible to enhance spatial ability in linked curricula. Thank you for attention my presentation. Thank you.
Thank you. Do we have questions from the audience? Well, I have a burning question. I think this is great work. I think you've touched on a topic that has real intellectual potential. I was wondering, have you compared a system like what you did with something like Minecraft? Because I know that Minecraft, you build 3D objects with blocks similar to your system, and there are ways of printing that out as well. So I'd be interested to hear any sort of comparison with Minecraft.
Usually they are using mouse, and they construct. But we want to emphasize typing, letter, symbol, and keyboard. So it's kind of a collaboration between the two. Then they can construct using Minecraft software. They can construct easily what they want and printing out using 3D printers. So this system is a kind of what Pepper said, hard fun. It's a kind of a hard fun, but Minecraft seems to be a soft fun. But we are interested in math education, so we want to provide students a little bit challengeable and hard environment so that they can study what mathematics education is searching. Symbolization, functional thinking, and a lot of symbolic expression. So.
Yeah. I think if I were to compare Minecraft and your system, it would be similar to comparing turtle graphics with Photoshop, right? So like Minecraft would be something that you just paint and make something very beautiful, but there's no sort of computation embedded in it. Whereas in your system, it's more about the systematic, procedural expression of the shape that you want, just like how you have to do it in Logo, in Turtle Graphics. But I think the challenge remains with the question I asked before, because I was trying to look at what would a complex program look like in your system to build an airplane or something like that, and I think there's space there to sort of come up with a representation of that shape that is understandable, right? Because otherwise, if it's too complex, it becomes like an STL file, right? It's like, might not be a difference when you open an STL file and looking at the script for a learner's perspective. Whereas in Logo, I think designing the language to be like human text is very much the core principle. So I think the emphasis on designing Logo is that when you read a Logo program, it's like reading a text that you would write to communicate with each other. So I think it's a lot harder to do with 3D because there's a lot of implicit things about 3D shapes and how to represent it. So that's something tough that you'll have to crack. Yeah.
So our system is based on symbolic expression, so that we can communicate symbolic expression to another person using SNS, social network system. So once it's similar to Scratch. So student can borrow another student symbolic system, and then they can add their idea. So if someone make an airplane, and then someone can change the shape a little bit. And then once they understand the structure of the symbolic system. So that's the reason why we adopt a smartphone system. They can construct 3D object using smartphone, and then they can send their symbol expression to another student using social network, and then they can add, and they can give some response. So in this case, symbolic expression is something to think about, and something to communicate, and something to be developed. And so symbolic expression is the most important learning object in our system for
Okay.
mathematics education and coding education.
Okay, all right. Thank you.